Humans have always looked up at the stars, wondering about other worlds. Could we live there? This is an old dream. The Earth is our home, but what if we could have another? The idea of changing a planet is called terraforming. It means making another world like Earth. Mars is a planet that calls to us. It is our neighbor in space, not too far, not too close to the sun. Venus and Mercury are too hot, the outer planets too cold and gassy. Mars is rocky like Earth, with evidence that water once flowed there. This makes Mars special, the most Earth-like planet in our solar system. The thought of terraforming Mars has been in stories for a long time. Writers dreamed of red deserts turning green, canals and cities under a blue Martian sky. Now science looks at these dreams. Scientists ask, can we do this? Is it possible? The answer is complex. It is perhaps the biggest engineering project humans could ever try. It would take many years, many people, and a lot of new science. This essay will explore the science of terraforming Mars. What is Mars like now? What do we need to change? How could we warm it? How could we make air to breathe? What tools do we have? What tools do we need? It is a journey into a possible future. A future where humans might walk on a green Mars. A future where Mars becomes a true second home for humanity. It is a difficult path, but the dream persists. To change Mars, we must first know Mars. Mars is a cold planet with an average temperature of -80 degrees Fahrenheit. Sometimes, at the equator in summer, it can get up to 70 degrees Fahrenheit, but at night it plummets again. Mars has a thin atmosphere, mostly carbon dioxide. The surface is a rocky, dusty red desert. Most water is frozen in the polar ice caps and permafrost. It is a beautiful world, but not welcoming for humans without help. Terraforming aims to make Mars more like Earth. This is the starting point for our great work. Terraforming Mars means changing its environment in big ways. We need to make it warmer, make the air thicker, and have liquid water on the surface. Each goal is a huge challenge and depends on the others. For example, a thicker atmosphere will help trap heat, making Mars warmer. Warmer temperatures will help keep water liquid. We need to raise the average temperature significantly. This would allow ice to melt and make the planet more comfortable. We need to increase the greenhouse effect on Mars. Mars needs a stronger greenhouse effect. We need to add more gases, lots more gases. This will increase the air pressure, needed for liquid water to be stable and for humans to live without pressure suits. And the composition of the air must change. We need oxygen. Finally, there is the issue of water. Mars has water, but it is mostly ice. We need that ice to melt and form lakes, rivers, and maybe even small oceans. Water is essential for life as we know it. So, finding ways to release this frozen water and keep it liquid is crucial. This involves warming the planet and thickening the atmosphere. All these changes are interlinked, a complex dance of planetary engineering. Warming Mars is the first big step. Without more warmth, nothing else works. The ice will not melt, and the air will stay too thin. How can we heat up an entire planet? One idea is to use greenhouse gases. These are gases that trap heat. Carbon dioxide is a greenhouse gas. Mars already has a lot of carbon dioxide in its thin atmosphere, but we need much more of it, or more powerful greenhouse gases. We could try to release carbon dioxide trapped in Martian rocks and polar ice. One way to release trapped CO2 is to heat the Martian surface. Some suggest building giant mirrors in orbit. These mirrors would reflect sunlight onto specific areas of Mars, focusing on the polar ice caps. The ice caps contain frozen carbon dioxide, dry ice, and water ice. Heating them would turn the dry ice into gas, which would go into the atmosphere. More CO2 in the atmosphere means more heat trapped. This is a positive feedback loop. More warmth releases more CO2, which causes more warmth. Another idea involves factories on Mars. These factories could produce powerful greenhouse gases like perfluorocarbons, PFCs. PFCs are very good at trapping heat, much better than carbon dioxide. Even a small amount of PFCs could warm Mars significantly. These factories would need a lot of power and would need to be built and operated on Mars. This is a big engineering challenge. We would also need to find the raw materials on Mars to make these gases. This requires careful study of Martian geology. Warming Mars is a slow process. It will not happen overnight. It will take centuries, maybe longer. Once Mars starts to warm up, we need to build its atmosphere. A thicker atmosphere is crucial. It provides air pressure, protects the surface from harmful radiation, and helps keep the planet warm. We need to add a lot of gas to the Martian air. The current atmosphere is too thin to support human life or stable liquid water. We need to increase its mass many times over. One source of atmospheric gas is Mars itself. Heating the polar caps releases carbon dioxide. Heating Martian soil, called regolith, can also release trapped gases. There might be large amounts of CO2 ice buried underground. If we warm the planet, this CO2 could vaporize and add to the atmosphere. This process is called outgassing. It would happen naturally as Mars warms. But we might need to speed it up. We could use industrial processes to extract gases from the rock, but carbon dioxide alone is not enough for a breathable atmosphere. We need oxygen. Humans need oxygen to breathe. Plants produce oxygen on Earth. So, one long-term goal is to introduce plants to Mars. First, we might use simple organisms like cyanobacteria or algae. These can survive in harsh conditions and perform photosynthesis. This would be a very slow process, taking thousands of years to build up enough oxygen. Water is life. For Mars to be a second Earth, it needs liquid water. We know Mars has water, mostly frozen. The polar ice caps hold vast amounts of water ice. There is also likely a lot of ice buried underground like permafrost on Earth. The challenge is to melt this ice and keep the water liquid on the surface. This requires a warmer planet and a thicker atmosphere. As Mars warms, the ice caps will begin to melt. The water ice will turn into liquid and start to flow. It might fill craters in low-lying areas, forming lakes and small seas. Underground ice will also melt, creating underground aquifers. It might even lead to springs and rivers on the surface. Seeing liquid water flow on Mars again would be a historic moment. The thicker atmosphere we build will also help keep water liquid. Air pressure affects the boiling point of water. With Mars's current thin air, water boils at a very low temperature. Even if it melts, it quickly turns to vapor. A thicker atmosphere raises the boiling point, allowing liquid water to be stable on the surface for longer periods. It allows for the formation of a water cycle, like on Earth, with evaporation, clouds, rain, and snow. This is essential for a habitable climate. However, Mars has a problem with keeping its water over very long timescales. Terraforming Mars is not just a dream. We have some technologies today that could help. We also know what kinds of new technologies we need. Our current robots on Mars are a good start. Rovers like Curiosity and Perseverance study the Martian environment. They analyze the soil and atmosphere. This information is vital for planning terraforming. Satellites orbiting Mars map the planet. They help us find resources like water ice. These are our eyes and ears on Mars. One current technology is solar power. Mars gets less sunlight than Earth, but solar panels can still work there. They could power early habitats and small-scale operations. Nuclear power is another option. Small nuclear reactors could provide more consistent power. This would be needed for larger industrial processes like factories to make greenhouse gases or machines to drill for underground ice. We are already designing such systems for future moon bases. These could be adapted for Mars. Looking to the future, we need more advanced technologies. We need much better ways to produce greenhouse gases on a massive scale. This might involve automated chemical plants. We need ways to efficiently extract water ice, perhaps large-scale drilling and heating systems. For oxygen production, we need to develop robust genetically engineered microbes. Terraforming Mars will not be quick, it will not be easy. The scale of the project is enormous. We are talking about changing an entire planet. The timescales involved are vast. Even the first steps, like warming the planet slightly, could take decades or centuries. Creating a thick, breathable atmosphere with enough oxygen could take millennia. This is not a project for one generation. It is a project for many generations. It requires patience and a very long-term vision. There are many scientific and engineering challenges. We still do not know enough about Mars. How much carbon dioxide is really trapped in the regolith? How much water ice is there, and how accessible is it? What are the unknown effects of trying to change a planet's climate? There could be unexpected consequences. The Martian dust is another problem. It is very fine and gets everywhere. It could damage equipment. It might also be harmful to human health if inhaled over long periods. Why should we even try to terraform Mars? What is the ultimate goal? The most obvious reason is survival. Humanity currently lives on only one planet. If a catastrophe happens on Earth, like a giant asteroid impact or a supervolcano, our species could be at risk. Having a second home on Mars would be an insurance policy. It would mean humanity could survive, even if Earth faced a disaster. This is a powerful argument for becoming a multi-planet species. Terraforming Mars could also unlock vast new resources. Mars has minerals and metals, it has water ice. These resources could support a Martian civilization. They could also potentially be sent back to Earth. A terraformed Mars would be a new frontier. It would offer new opportunities for science, for industry, for human settlement. It could drive innovation and technology in ways we cannot yet imagine. It would be a new world to explore and understand, a new place to call home. The act of terraforming Mars could also change humanity itself. It would require us to work together on a global scale. It would push the boundaries of our knowledge and abilities. It could give us a shared purpose, a grand project to unite us. The challenges are immense, but overcoming them could lead to a more mature and capable human civilization. It could inspire new art, new philosophy, new ways of thinking about our place in the universe.